directional derivative. If phi of xyz is a scalar function and vector d is a given direction, then del phi dot n cap, where n cap is equal to d vector divided by mod vector d, is called as the directional derivative of phi along n cap, tangent plane and normal line. If phi of xyz is equal to c, be the equation, and p of xyz is any point on it, then the equation of a tangent plane at P is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Equation of the normal line is x minus x1 by a is equal to y minus y1 divided by b is equal to z minus z1 divided by c, where a, b, c is given by dou phi by dou x at xyz, dou phi by dou y at xyz, dou phi by dou zx at xyz. Next we have some more notes. Divergence of a vector field, divergence of vector v is equal to 0, is called a continuity equation of an incompressible fluid. A vector v whose divergence is 0 is called a solenoidal vector. Vector divergence gives the total gain in the volume of the fluid per unit volume per unit time. Divergence gives the total gain. Divergence gives the total gain. Divergence gives the total gain in the volume of the fluid per unit volume per unit time. Curl of vector v is equal to 0 is called the irrotational vector. Divergence of vector v is equal to 0 is called the solenoidal vector. Curl of vector v is equal to 0 is called the irrotational vector. If for a given vector v, if you find the divergence of that, if it is equal to 0, then it is solenoidal vector. For a given vector v, if you find the curl of vector v and if it is equal to 0, then it is the irrotational vector. Curl means rotation. Usually the physical meaning of curl is rotation. It gives a measure of the angular velocity at any point P. Del phi is a vector normal to the surface phi of xyz is equal to c, and del phi divided by mod del phi is the unit normal vector to the surface. Okay, now let us see some problems here. Find the unit normal vector or unit vector normal to the surface. There is a surface given at the given point. See, we have to find the unit normal vector. To find the unit normal vector at the given surface, see, for the given surface at the given point, see, this is the scalar given. This is a scalar function. This is the scalar function. Surface is a scalar function. Okay. For this scalar function, let us denote this as phi. Phi is equal to what? X square y plus 2xz. Okay. This is this left hand side LHS is a scalar function. We have defined phi. We know that del phi. Del phi is vector normal to the surface. I just have read. Del phi is a vector normal to the surface. Phi of xyz is equal to c. Del phi is a vector normal to the surface. Del phi is a vector normal to the surface. Which will be a vector normal to the surface? We have to find the vector normal to the surface. Which is vector normal to the surface? Del phi is vector normal to the surface. So for the given phi, for the given surface, we have to find the del phi. Okay. So del phi is a vector normal to the surface. Del phi we have to find. What is del? Del is equal to dou by dou x I plus dou by dou y j plus dou by dou z k into phi. What is given phi? Phi is the surface. Phi is the surface. Phi is x square y plus 2xz. See, this term I have to multiply with this term. Now, see, here I, j, k terms are not there. Completely it is a scalar function. I have to multiply this for throughout this equation. So, dou by dou x of this complete term into I plus dou by dou y of this complete term into j plus dou by dou z of this complete term into k. Now, let me partially differentiate with this with respect to x. What is the meaning of dou by dou x? The meaning of dou by dou x is partially differentiate this with respect to x. Okay, differentiation of x square y is what? 2xy plus with respect to x means x differentiation 1, so it is 2z into I plus with respect to y, the same term with respect to y we have to do. With respect to y means y differentiation 1, so it is x square plus here y term itself is not there, it is 2xz. Y term itself is not there, so it is 0 plus with respect to z, if I differentiate this with respect to z, it is x z is not there, 0 plus z differentiation 1, so it is 2x, 0 plus 2x into k. Now we have differentiated this with respect to x, y, z. Okay, now it is del phi. Del phi I have simplified, and this is your del phi. Now del phi at the given point. Del phi at the given point 2 minus 2, 3. So del phi 2 minus 2, 3. In place of x, put 2. In place of y, minus 2. In place of z, 3. So I have put, and I have got this minus 2i plus 4j plus 4k. This is a very simple steps. You can follow this. We have one more question here, right? Okay, we have found the vector normal. See, this is just vector normal. Del phi is a vector normal. What we have to find? We have to find the unit vector normal. Unit vector normal is what? Unit vector normal is del phi by mod del phi. See, whatever we found del phi, that we have to take the absolute value and we have to divide it by that. So it is unit vector normal to the surface is given by n cap, that is del phi divided by mod del phi. Del phi we found, that is 2 minus 2i plus 4j plus 4k divided by the modulus of that del phi is nothing but what? The square of this I component coefficient, square of this j component coefficient, square of this k component coefficient. I repeat once again, square of I component coefficient, square of j component coefficient, square of k component coefficient, minus 2 square plus 4 square plus 4 square. Now when you simplify this, this is written as it is. What is this? 2 square is 4, 4 square is 4, 4 square is 16, 4 square is 16, 16 plus 16 is 32, 32 plus 4 is 36, root 36, root 36 can be written as 6, and here I have taken 2 in the numerator. 6 will be divided by this 2, 2 ones are 2 3s are, so I will be remaining with minus I plus 2j plus 2k divided by 3, and this is n cap. N cap is the unit normal vector for the given surface at the given point 2 minus 2 3 is I minus I plus 2j plus 2k divided by 3. Similarly, if you solve the second problem, you will get the answer n cap is equal to 3i plus 4j minus 6k divided by root 61. Please do this. Now we'll go for the next type of problem in this. Find the directional derivative of the following. Phi is equal to phi is equal to x square yz plus 4x z square at the given point along the direction. Here we have to find the directional derivative. Here we have to find the directional derivative. For the directional derivative, what is the formula? Directional derivative for the given direction is given by del phi dot n cap. Del phi dot n cap. I have to find del phi, then I have to find n cap, then I have to take the product of this dot product of these two. Okay. Now let me see how we have to solve that problem. This is a given surface. For the given surface at the given point along the given direction, we have to solve this problem. See, let me take this as phi. Phi is equal to x square yz plus a 4x z square. We have to find del phi. That is a vector normal to the surface. What is a vector normal to the surface? This is a vector normal to the surface. Del phi. Del phi is equal to what? Dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k. Del phi. Del is nothing but dou by dou x, dou by dou y, dou by dou z. Here it is phi. That's why I have multiplied phi. That's all. Okay. Now here what I have to do? See, dou by dou x as it is there. Dou by dou x as it is there. What is phi? Phi is given right in the problem. That phi I have substituted here into I as it is, into I as it is, plus dou by dou y as it is. Phi is what? This complete term I have substituted. I is as it is again, plus dou by dou z as it is, and phi is substituted and k is as it is. Now after substitution of this phi, what we have to do? We have to differentiate partially this with respect to x, y and z. Okay. This with respect to x, if you do, what you will get? See, this with respect to x, x square yz, differentiation of x square is 2x, yz as it is, plus 4 into z square with respect to x differentiation 1, so it is 4z square into I plus dou by dou y is nothing but with respect to y. With respect to y means y differentiation 1, so it is x square z plus this with here y term is not there. Completely with respect to y means this one will be constant and treated as constant, and this will be 0 into j plus with respect to z means x square y as it is, z differentiation is 1 plus z differentiation is z square differentiation is 2z, so 2 4s are 8, 8xz into k as it is. So we have differentiated this with respect to x, y and z. Now at a given point, which is the given point? The given point is 1 minus 2 minus 1. So del phi at the given point 1 minus 2 minus 1. In place of x substitute this one, in place of y substitute minus y minus 2, in place of z substitute minus 1. When you substitute this, you will get 8i minus j minus 10k. Now what you have to do? You have to find n cap. To find n cap, what is the formula? At the given direction, we have to find the unit vector along the given direction. Along the given direction means, what is the given direction? Given direction is 2i minus j minus 2k. So when the direction is given, you have to find the unit vector along the given direction. Okay, along the given direction. This is the given direction. Along the given direction, you have to find the unit vector, not at this vector. When the direction is given, you have to find the unit vector along the given direction, not at this vector. In the previous problem, we have found the unit vector along this vector, but when the direction is given, see in the problem, direction is given right along this direction. So when the direction is given, so you have to find the unit vector along the given direction. So along the given direction means n cap is equal to the same, you just write it here, and divided by root of this I component square plus j component square plus k component square. I is 2, I component coefficient is 2 square plus minus 1 square plus minus 2 square. So 2 square is 4. 1 square minus 1 square is 1, minus 2 square is 4, 4 plus 4 is 8, 8 plus 1 is 9, root 9 is nothing but 3. So this is n cap I got. Now what is the directional derivative? Directional derivative is given by del phi dot n cap. Directional derivative is given by del phi dot n cap, that is equal to del phi whatever you got here, that is 8i minus j minus 10k into or dot n cap whatever you got here, just write it here and divide by 3, just you can write it in the denominator, that is not a problem. But in the numerator what you have two terms, right? You have two terms and you have to multiply these two terms. See, I into I will be 1, I into j 0, I into k 0, don't forget this please. J into I will be 0, j into j is only 1, j into k will be 0. Similarly, k into I 0, k into j 0, k into k will be 1. Same components will give you 1. The different components will give you 0. Now let me multiply. Usual multiplication, how we will be multiplying. In the same way, let us multiply. 8 2s are 16. Okay, 8 into 2 I have written. Okay, 8 into 2 into I is 1. That's why I into j 0, I into k 0. That's why I have not multiplied those terms. Okay, now come to this second term. For the second term, j into I will be 0. That's why I just left it. Then minus into minus is plus. Okay, plus minus 1 into minus 1. Do it like this. Plus, okay, for always plus, okay. J into j is 1. Okay, that's why I'm multiplying these two components. Now minus 1 coefficient multiplied. Plus, come to the third term. For the third term, k into I is 0, k into j is 0, k into k will be 1. That's why I'm multiplying these two terms. So minus 10 into minus 2. Now just simplify this, you will get 37 divided by 3. Similarly, one more problem we had, right? For the directional derivative, see, for the given surface at the given point and along the given direction, you can solve this problem and you will get the answer, that is del phi dot n cap. Similarly, del phi dot n cap, that is 376 divided by 7. This is the solution for the second problem.